This is stoichiometry tutorial number 4. You will need the periodic table, calculator, a map of mole lands, and the worksheet that accompanies this tutorial. This tutorial will help you solve problems using molarity and using 22.4 liters are equal to 1 mole at STP. Problem number 1 states that how many liters of nitrogen gas is needed to react with 44.8 liters of hydrogen gas to produce ammonia gas? And so first we must write our correct equation. So we are looking at nitrogen gas. Nitrogen gas is diatomic, and it is reacting with hydrogen gas. Hydrogen is also diatomic, and it is producing ammonia. Ammonia has a formula of NH3. Now that we've written the chemical equation correctly, we need to balance it. So you see we have 3 hydrogens here, only 2 there, and they begin balancing. Common denominator of 6. We also have 2 nitrogens here, only 1 here, so we'll place a coefficient of 2. So we have a ratio of 1 to 3 to 2. Now we can start looking at the setup for this problem. We are given that we have 44.8 liters of hydrogen. So we're wondering how many liters of nitrogen gas are needed to produce our ammonia. So let's start with the setup. 44.8 liters. This is hydrogen gas. So we want to set liters opposite. And let's try to get to where we can use that mole ratio. So if we set liters opposite, we know that there are 22.4 liters in 1 mole. That's the first step. Now that we are in moles, we can set up a mole ratio. And so we're going to be looking at these 2 right here. And we'll use our coefficients to set up our mole ratio. So for our mole ratio, we want to put moles of hydrogen opposite. So we can see from our coefficient that we have 3 moles of hydrogen for every 1 mole of nitrogen. Now that we have our mole ratio in, we have gone from hydrogen to nitrogen. We've used that mole ratio bridge. So now that we have nitrogen, we can make an easy conversion to the liters of nitrogen. So we can use that same conversion that we had originally used here. So we know that 1 mole of nitrogen gas is equal to 22.4 liters. Now we are in liters of nitrogen gas. So you'll calculate 44.8 divided by 22.4 multiplied by 1 divided by 3 and then multiplied by 22.4 to arrive at your liters of nitrogen gas. Sorry, it's getting really glitchy there. So we have 14.93 liters of nitrogen gas. Number 2, how many liters of ammonia are produced when 89.6 liters of hydrogen are used? And it's in the same reaction. So I'm going to rewrite that. We have N2 plus H2 yields NH3. And remember, it has to be balanced. So there we go, same equation. This time we're given 89.6 liters of hydrogen. And we want to know how many liters of ammonia would be produced if we were starting with 89.6 liters of hydrogen. So we're going to look at just these 2, and we're going to compare them when we get to the mole ratio. So it is very similar to the problem that we just worked. You're just using one of the reactants and one of the products now, and you'll make the mole ratio with those 2. So starting out, you have 89.6 liters of hydrogen. And we know that there are 22.4 liters of gas in 1 mole of hydrogen. So now it's time for the mole ratio, where we convert from moles of hydrogen to moles of ammonia. So we have to use the mole ratio bridge, and we're going to use the coefficients that we have in our balanced equation. So we want to put hydrogen opposite. So we have 3 moles of hydrogen to every 2 moles of NH3. Now that we have used the mole ratio and converted from hydrogen to ammonia, now we have to just go back to liters. If you're looking at your map of mole land, you can see the path that we're taking fairly easily as you go from liters to moles, use the mole ratio bridge, and then back to liters. So now we know that 1 mole of ammonia is equal to 22.4 liters of ammonia. So that will get us our answer in liters of ammonia. To make this calculation, you have 89.6 divided by 22.4 multiplied by 2 divided by 3, then multiplied by 22.4. So we have a total of 59.7 liters of ammonia. This is the third and final problem. It's a different equation. It asks us to calculate the moles of iron produced when 1,700 milliliters of 6 molar iron 3 perchlorate reacts with potassium. So first we have to figure out what we've got going on. It tells us we have iron 3 perchlorate reacting with potassium. So let's get started there. Iron 3 perchlorate. We've crisscrossed the oxidation numbers, and it reacts with potassium. So in order to predict the products, we need to identify the type of reaction. You have a single element reacting with a compound. And so potassium will replace iron. So when potassium replaces iron, we have potassium chlorate, and iron is now single. We have our chemical equation written correctly, but now we have to balance it. We have, sorry about that, this is not iron 3 chlorate, this is iron 2 chlorate. Maybe you caught that before I did. And so we have two chlorines and 6 oxygens, and so we need to adjust that here. And then now we need to adjust the number of potassium, and this will be 1 to 1. So the equation is balanced, and now all we need to do is the setup. But this time we're not using 22.4 liters in 1 mole. We're going to use our molarity that is given to us. So let's look at what we have started with. We're given 1,700 milliliters. Now remember I said molarity can be used as a conversion factor. So 6.0 molar is 6.0 moles per 1 liter. But we also know that 1 liter is equal to 1,000 milliliters. And so we can kind of take a step and cheat where we just put in our 1,000 milliliters and cancel that out without really making a conversion, since we know that 1 liter is equal to 1,000 milliliters. So I'm going to set it up so that I arrive at moles. We have 6.0 moles of iron 2 perchlorate. I'll get it right this time. And this is over 1,000 milliliters of solution. So you can see your milliliters cancel out. Now we're in moles of iron. Iron 2 chlorate, to be exact. And so we are in moles of iron 2 chlorate. We want to find moles of iron. So we need to use the mole ratio. Anytime you're going from one compound to another, the mole ratio is what has to be used. So we're going to start with this down here. We're going to put moles of iron 2 chlorate on the bottom, and we're going to look to our balanced chemical equation. We have 1 mole of iron 2 chlorate. Now we need to look at the moles of iron. We have 1 mole of iron. This will allow us to arrive at our answer. We'll calculate 1700 multiplied by 6 divided by 1000, and then we just have a 1-to-1 ratio here. So our answer, 10.2 moles of iron. And this is the end of the stoichiometry tutorial number 4.